So let's learn about synchronous I/O. I/O means input output, right? Now blocking the calling thread while I/O completes can reduce performance and affect vertical scalability. Now what's vertical scalability? Scaling your server using hardware components. That is what vertical scaling is. Okay, and distributing load accordingly. Now blocking the calling thread while output completes can reduce performance and affect vertical scalability, right? Now whenever you are blocking a calling thread, when like you have output operations that getting completed or it's loading, right, and you are blocking other calls, that can reduce the performance, right? A synchronous input output operation blocks the calling thread while input output completes, right? So what synchronous means that when one operation is working, it blocks other operations, right? You cannot proceed, other operations cannot proceed. It can only proceed once it's completed. This is completed, then this can proceed. This won't be able to proceed. Once this is completed, then this can proceed, right? So 1, 2, 3 in this first come first serve, right? The calling thread enters a wait state and is unable to perform useful work during this interval, wasting processing resources, right? So processing resources will be wasted. So what we can do? Common examples of I/O include what are common examples of it? Common examples of I/O are what? Those are first is what? Retrieving or persisting data to a database or any type of persistent storage, right? Retrieving or persisting data to a database or any type of persistent storage. Second is sending a request to a web service, right? That can also be input output operation. If you are sending a request to web service, right? Web service, that also comes under this. Posting a message or retrieving a message from a queue retrieval, right? Of message or posting message to queue, right? That is one thing. Now what is third example? Third is writing to a or read from local file. That is also input output operation, right? Writing or write or read from local file. That is one thing. Now this is also a type of anti-pattern, right? All of the things that we are understanding till now, the first one was improper instantiation, monolithic persistence, noisy neighbor. Now synchronous I/O. These are all what? Performance anti-patterns. These are performance anti-patterns due to which our performance of the server can affect, right? The anti-pattern typically occurs because this type of anti-pattern typically occurs because of what? Because it appears to be the most intuitive way to perform an operation, right? Because it appears to be most intuitive way to perform an operation. The application requires a response from a request. If the application requires a response from a request, that is also input output thing, right? The application uses a library that only provides synchronous methods for I/O. If any application that we are using that does not provide asynchronous, it just provides synchronous method, that can also lead to this anti-pattern. Now an external library performs synchronous I/O operation internally. A single synchronous I/O can block entire call chain. So these are the like anti-patterns. Because of what this type of anti-pattern can occur. You can learn more about it, try to find some resources or learn from Medium. I generally refer Medium and Dev2, where you can learn from. Of course, AI, or you can learn from ChatGPT. Ask it to explain you in the simplest term where a child can understand. You will try to remember from that example, or try to ask ChatGPT to use real life example. It will be very easy for you. Let me just try to explain you synchronous I/O using real life example. Just a second. So explain synchronous I/O anti-pattern using real life. Okay. Now let's see how it explained. So what it did. First, what is synchronous input output, right? Synchronous I/O means when you ask for data, read write from a file, database, network, your program waits until that operation finishes before doing anything else, right? So that is what a synchronous I/O means, right? Now whenever you are asking any data read or write from a database or file or network, then it is known as synchronous I/O. If the operation takes long time, everything else is stuck waiting, right? If it takes long time, then other things will be stuck. What is why it's an anti-pattern sometimes, right? In server or app design, using synchronous IO in the wrong place, especially in places that handle many requests, can block other work from happening. Now, what is the real life analogy? The pizza shop. The pizza shop examples are world famous. Here also, our AI has used the same example. So, synchronous IO style. A customer order pizza, right? First step is a customer orders the pizza. Now the chef makes the dough, puts in the oven, and stands there doing nothing while it bakes for 15 minutes. That's a waste of this resource, right? He could have done other things. Third is only after the pizza is done does the chef take the next customer's order. Problem: if baking takes too long, customers line up out of the window, out the door, right? The oven, what I said, out of the window. The oven is working, but the chef is idle instead of preparing the next pizza, right? Now better is what asynchronous style. Customer orders pizza, chef preps pizza, puts in the oven while it's baking. The chef starts making next pizza for the next customer. When the oven beeps, the chef takes it out and serves. Benefit: the chef is always working. Customer is served faster. In software terms, synchronous IO is anti-pattern. This is fine in small script, but in web servers or high traffic apps, it blocks other users and slows everything down. Okay. This is the synchronous IO. This is async. You have just await and used async await, right? We can use what Exos for this. Exos is a Node.js library. You can use that. Now let's learn about extraneous fetching. So let's learn about extraneous fetching. Let me write the topic first. Extraneous. So what is extraneous fetching, right? Extraneous fetching means retrieving more data than you actually need from a database. That is sort of what we have learned already about, which was what? This topic we have already learned, right? If you go up, I can show you. This was also monolithic persistence, a single DB. In noisy neighbor, yeah, we have learned. We have just saw the example, but extraneous fetching means fetching more data than required, right? Fetching more data than required, right? There is a classic example, like when you use SQL, right? If you use SQL, you fetch unnecessary data if you don't write proper query, right? So what we can use GraphQL instead, which will just bring the required data, right? It's a kind of inefficiency because you ask for everything, even if you only need a small part, right? This what it does, it wastes a lot of bandwidth, memory, and processing time, right? So this is not good actually. So you shouldn't be doing that. Of course, GraphQL learning curve is very steep. You need to learn. The learning takes some time, but it's beneficial for your system. Your system performance will increase exponentially. Now, what is real life analogy for extraneous fetching, right? What is a real life analogy? Imagine like you are hungry and want one cheeseburger. So instead of ordering one burger, what you do, you order the entire menu from the restaurant, eat just the cheeseburger, throw away the rest. That is not cool, right? It's a wastage of food and of course the resources and whatever food materials that we have used. It is not good. This is an extraneous fetching. You wanted just a cheeseburger, but you have ordered everything in the menu. Okay, in software terms, what we can say, let's suppose there is some user, right? There is some user. For this user, we just need its age, but we fetch every detail of that user from the DB. So this is extraneous fetching, right? This is not common cause. Is what in SQL you can say it's select. So if you use this thing, it's a death bomb, right? Don't use it. Try to just make sure whatever fields you need. Let's suppose you can write a query like select name from users. Users is the table name and name is the field name, right? So it will just select the name from the users table. Now these are the common causes: overfetching in REST API, of course, returning entire files when only a portion is required. So these are the common causes. Why it's bad? Of course, the performance will be slower. Why it's bad? Why extraneous fetching is bad? Slower performance, right? Lower. The performance gets low. What else? Higher cost in cloud environment because of network and storage. So cost goes up because more storage, right? More storage, more network bandwidth. Okay. What is third? Memory waste. Of course, RAM will be wasted because of unnecessary utilization. Memory waste. Fourth, leak sensitive data unintentionally, right? It can leak sensitive data. Of course, it will be unintentional. Nobody wants to leak sensitive data intentionally until there is a culprit in your company. Now that was about external fetching, asking for a lot of data but only using a little bit. That is what external fetching is. Now what next topic is busy database. Right? Let's learn about busy database. This is also a type of anti-pattern. These are all type of anti-patterns, right? Busy database. So what is busy database? What does it mean by busy database? A busy database is one that's handling too many requests at the same time, so it becomes slow or unresponsive, right? If your database, this is your database, right? This is your DB. Just create image. This is your DB. If it is handling too many requests, there are too many requests coming to this DB, and then it becomes slower. The performance, slow performance because it's serving too many requests, right? R1, R2, and R3 simultaneously. Think of it like calling customer service during peak hours. You are stuck on hold because the agents are already talking to other customers, right? Because whenever you, in earlier times, now it's customer care is replaced by AI. But in earlier times, what used to happen whenever we used to call a customer service during the peak hours, which are around 12 to 6 p.m. So what happened in that time? You used to wait in the queue, right? Like whenever our customer representative will be free, we will you can have a talk with them, and that we will record that call. So that is how it works, right? So same analogy can be used in this database thing. So if R1, R2, and R3 are getting served, so R4, R5, request 5 and request 6 will be on hold because these are already getting served by the DB, right? And of course the performance will be slower because these requests are on hold. The user will face the slow performance by the app. Now, why database get busy? Why databases get busy? As I said, if you are requesting or you are creating query for your database and you have divided, instead of creating one request, one huge request, you have divided it into multiple small requests. That is one thing. So too many simultaneous queries. Second is long running queries. If you have multiple joins and all, then it's a long running queries on a DB, right? So that is second thing. Inefficient design. If there are no indexes, right, then you have to find that thing. You have to search for search that index on other table if there is no mapping. That is third thing. Fourth is what? Log contention. Multiple operations waiting for the same row or table, right? If log contention means if you have there is a database log thing, right? You know that, right? If you are creating basically in transaction or where money is involved, there is a log thing in DB where we need to log that table. So other this is like a architecture design which we can design in the form of class and methods or functions, where we log that particular table so that other request cannot interact with it, right? So that can also be a one thing because that table is locked. Other request cannot interact with it because that is locked, right? And we don't want other things to make changes. One change can only happen at a time because it's a transaction or it's a amount thing, right? So that is one thing that is also a requirement. So that is log contention. Fifth is background jobs competing with live requests, right? If there are backups or analytics running during a peak hours. A real life analogy, imagine a pizza shop, right? Imagine a pizza shop. There are only two ones. These two ones we can refer to two database connections. Now at lunchtime, 20 pizzas needs to be baked. Orders pile up and some customers wait a long time, right? Because the orders are piled up, 20 pizzas, one pizza can be served at a time, even if you keep on ordering, because there are only two ones. Even if you make multiple pizzas, only two ones are there to serve, to bake that pizza, right? So that's again, customers will have to wait for a long time. In software terms, when a database is busy, what happens? Queries start queuing up. Response times get slower because queries are queued up, right? Applications may time out or crash if they can't get data in time. So that is one thing. That was about busy database. Now let's learn about next thing, which is busy frontend. What is a busy frontend? FE means frontend, right? Busy. Hopefully this video is getting recorded, right? Okay, great. Busy Frontend. So, what is Busy Frontend? So, Busy Frontend is when the user interface or the UI, the part of the app the user sees is overloaded with the work and can't respond quickly to user actions. If there is a UI which is overloaded with work or it's hung, right? And it can't respond. It's unable to respond to users interaction, then that is a busy front. Let's suppose you click a button but the page freezes for a moment before doing anything. Suppose there is a UI on this phone, there is a button, you have clicked on this button, right? You have clicked on this button, but this button is not responding. Now why front end gets busy, right? What are the causes of it? What are the causes, right? What are the causes of fee? What are the causes of busy front end? The causes are basically, first is heavy JavaScript execution. So if your JavaScript files, JS files contains loops, those are running on n cube or n square TC, time complexity. If there are complex animations, of course, complex animation are really a huge contributor to busy front end, right? So complex animations, this would require huge bandwidth. Second is what? Blocking synchronous call. If there are input output operations or network calls or database calls, so if they are blocking, that can be one contributor. Synchronous calls. So waiting for, first example can be waiting for what? Large file to load. If you are loading a PDF, that can be one thing. Second can be doing expensive computation without yielding, right? Doing expensive computations on FE. If backend is not sending data with maps and all, then you try to map it on front end. That is one thing that can lead to front end getting busy, or too much DOM manipulation at a time. Too much DOM manipulation at same time. So what it can be, DOM manipulation means uploading thousands of elements in one go, right? Uploading thousands of or onboarding thousands of elements on one single page. So onboarding thousands of elements in one go. That can be one thing. Fourth is what? Large rendering task, right? Large rendering task. If there are tasks which needs to be rendered, like complex layout, big images or tables. Examples can be tables, tasks, or images that is rendering. That can also be a contributor to busy front end. That will take front end to a long time to respond. That was about it. Now real life analogy. What can be real life analogy? Real life analogy, let me explain you with an example. Imagine you are a fast food cashier who takes the order, cooks the burger, makes the fries, and fills the drink. So before taking the next customer's order, while they are doing all that, the next customer can't even place an order. That's your busy front end, the cashier. Because you are the owner of the shop, you don't have money to pay to extra employees. What you do everything by your own. So doing everything by your own, not having a server, makes your front end busy and laggy. You take the customer's order, you cook the burger, you make fries, you fill the drinks, and before taking the next customer's order, you are doing all that. So there is no, the next customer have to wait for a long time, right? So that's your busy front end, and the cashier is overloaded. In software terms, let's suppose there is some code, right? We have wrote some code, and your code gets freeze due to some large request or whatever things that we have seen, right? This JS, or there are complex animations or loops due to which your page stops responding or responds after 5 or 10 seconds. That can be a symptom. Now what are symptoms of busy front end? Clicks, scrolls, or typing feel laggy. That is one thing. Animation becoming slutter. It becomes slower basically. Page becomes unresponsive for seconds at a time, right? You keep on scrolling the page, but that becomes unresponsive. It doesn't scroll in the way it should be, right? Browser shows page is not responding. That type of things are symptoms of busy front end. How to fix it? Right? How to fix busy front end? How to fix it? Break clean code principles are really helpful here. But yeah, break big task into smaller. That can be one thing. Like you can use set timeout for some task. After set timeout, it will stop running that task. Second is quest animation frame. You can use that. What you can use? You can use web workers. Use web workers for heavy computation. Web workers are what? It runs in background, right? So it runs in background. Actually, new concept for me. So web workers, right? Web workers. What are web workers? Are a feature in modern web allowing JavaScript code to run in background threads separate from the main execution thread or a web page. This is actually a new thing for me as well. But yeah, you can use web workers and for like heavy computations. You can use web workers. This is a really cool thing. So you can use web workers. Now avoid unnecessary rendering. Avoid unnecessary rendering. You can do this. Fourth is what? Optimize images and assets. Fifth is what? Use async operation to prevent blocking. So you can do that as well. So try to use async operation to prevent the blocking. Don't use synchronous operations. So in short, what is a busy frontend? Busy frontend is like cashier who tries to cook, serve, and clean all at once. While the line grows longer, you keep frontend free. You keep frontend free by delegating heavy work and keeping tasks small. Okay, so you can keep frontend free by delegating the small task. You can delegate those tasks to your server instead of working or calculating or doing computation on frontend itself and using the device resources. So you can delegate that task and wait for that API to request in async manner instead of synchronous. So that is one way. That was about busy frontend. Actually, we have seen busy frontend as well earlier, right? I'm not sure. I think we saw it. Okay, we have shown n plus 1 queries, not busy frontend. My bad. So now comes chatty IO. This chatty IO. Chatty input or output.